Hello everyone. Today we are going to understand multi-level feedback queue scheduling. Okay. So CPU scheduling algorithm used in operating system. Okay. See, introduction. In operating systems, CPU scheduling decides which process gets the CPU when multiple processes are ready. Multi-level feedback queue (MLFQ) is an advanced scheduling algorithm that uses multiple queues with different priority levels. Allows dynamic priority changes based on process behavior, combines the advantages of priority scheduling and round robin scheduling. See, so in an operating system, multiple processes often want CPU at the same time. Okay, so scheduling is like a smart traffic controller. It decides which process gets the CPU and for how long. So one of the most flexible approaches is the multi-level queue feedback queue, or like MLFQ for short. Okay. Then key features of MLFQ: multiple queues. Each queue has a different priority level. Then higher priority queues are checked before lower priority queues. Feedback mechanism: processes that use too much CPU time get demoted to a lower priority queue. Processes that wait too long in a lower queue may get promoted to avoid starvation. Then time quantum, time slice. Each queue has its own time quantum. Higher priority queues usually have smaller time slices for quick response. Lower priority queues have larger time slices. Then starvation prevention agile techniques are applied to promote waiting process, ensuring no process is indefinitely delayed. Basically, see. So the main idea behind EMLFQ is simple. Okay, we have multiple queues, each with a different priority level. Higher priority queues are checked first. Okay, so meaning process in them get faster attention. Okay, so a process doesn't stay in the same queue forever. It's like its priority can change based on how it behaves. This is called feedback. Okay, then see how it works. A new process enters the highest priority queue. If it uses up its time quantum, it is moved to a lower priority queue. If it yields CPU before the time quantum ends, example waiting for IO, it may stay in the same queue. Then the CPU always selects a process from the highest priority non-empty queue. See, so basically, if a new process if a new process enters the topmost queue which has the highest priority, okay, then the CPU gives it a fixed time slice, like a small window to run. Okay, then if the process finishes within that time, it's great, it stays at the same priority level. Okay, so if it doesn't finish, it gets demoted to a lower priority queue for the next turn. Okay, so meanwhile, if a process waits too long in a lower queue, it can be promoted to avoid being ignored forever. Okay, this prevents starvation. Okay, now see example. Imagine we have three queues. Okay, queue 0, the highest priority with a 4 ms time slice. Q1 medium priority with 8 ms. Q2 lowest priority with 12 ms. Okay, suppose like a process P1 arrives and starts in Q0. It runs for 4 ms but still needs more time. Okay, so it moves to Q1. Then another process is P2 arrives and finishes within its 4 ms slice in Q0. Okay, so since the CPU always picks the highest priority non-empty queue, So P2 gets executed first. That's how MLFQ adapts like dynamically. Okay. See, basically MLFQ is brilliant because it treats interactive process like typing in a text editor quickly, like while still allowing CPU heavy tasks to complete eventually. Okay, so it balances responsiveness and fairness. Now see advantages and disadvantages. Flexible adapts to both CPU bound and IO bound process, reduces average waiting time for interactive processes, prevents starvation using agile. See, it's flexible and adaptive. Then short tasks get quick attention. Then long task eventually finishes without starving. Okay. Now see disadvantages. Complex to implement due to multiple queue, requires careful tuning of time quanta and priority roles. See, it's a bit complex to implement. So choosing the right time slice and priority roles is crucial sometimes. Okay. So conclusion is multi-level feedback queue is one of the most practical scheduling algorithms used in modern operating systems because it balances responsiveness for interactive processes and fair CPU allocation for long-running processes. See, so the multi-level feedback queue is like a smart elevator system, fast for quick stops but still fair to those going to the top floors. It's widely used in modern operating system because it balances speed and fairness in scheduling. Okay, see, uh, imagine a bus office with many employees, so each needing a meeting room to work. Some employees like have quick task, others have long projects, and the manager wants everyone to get a fair chance. Okay, so this is exactly what a CPU scheduler faces, like process waiting for CPU time with different needs. Okay, so multi-level feedback queue or MLFQ acts like a smart manager. It decides who gets the CPU first and it learns from the behavior of each process. Okay, and MLFQ is built on two main principles. First one is multiple queues. Each queue has a different priority level, so the topmost queue has the highest priority. Then feedback, like process can move between queues depending on how long they run or how they behave. So this makes it dynamic and adaptive. Okay, unlike static priority scheduling. Okay, so how multi-level feedback queue working, how it works, like see, first one is new process entry. Okay, so any new process enters the highest priority queue. So think of this as a giving a newcomer the benefit of the doubt, so they get fast access to the CPU. Then time slice. Each queue has a predefined time slice, a small window in which a process can run. If the process finishes within this slice, it stays happy in the same queue. Okay, then demotion. So it's like if a process doesn't finish in its allocated time, it gets moved down to a lower priority queue. Okay, so this is because long running tasks shouldn't block shorter ones indefinitely. Then fourth is promotion. So, so in promotion, to prevent starvation, any process waiting too long in a lower priority queue can be promoted to a higher priority queue. So this ensures fairness. Okay, so the system rewards short interactive process and gently penalizes long running CPU intensive processes, and all while keeping everything fair. Okay, So why MLFQ is it's powerful? So basically MLFQ is useful because it solves two common problems. First one is responsiveness. Okay. Then fairness. First, in responsiveness, interactive tasks get quick CPU attention. Then fairness. In fairness, long tasks eventually complete, avoiding starvation. So it's like a hybrid approach that combines the strengths of priority scheduling, round robin, and agile strategies all in one system. Okay. So basically, multi-level feedback queue is a combination of round robin agile strategies all in one system. So here are some points to remember. First one is time slices matter. So in time slices matter, too small and context switching overhead increases. Okay. So too large and short tasks get delay. Then dynamic priority adjustment is the key. So it's what makes MLFQ adaptive. Then starvation prevention is like crucial. So that's why promotion are used for waiting processes. So think of it as a smart queue system in the theme park. So fast passes for quick rides, but no one waits forever. Okay. So basically the multi-level feedback queue is like a living scheduling system. It observes, learns, and adapts to process behavior. And like short interactive tasks get fast attention. Okay. So long task completes eventually, and like no process is left waiting indefinitely. Okay. So that's why it's widely used in modern operating system. Okay. So next time you type on your computer and the system responds instantly while running heavy programs in the background, so thank MLFQ for its clever scheduling magic. Okay, that's why multi-level feedback queue is it's like a great. Okay, thank you.